Right now, you are alive in one of the rarest moments in the entire history of the universe. Not because of who you are, or where you are, but because of when you are. You are alive in an era of the universe when it is bright enough to see itself, when stars exist, when galaxies still cluster, when the sky is full of light. And one day, long after every human is gone, long after every star has died, the universe will not look like this anymore. It will be a darker, emptier, quieter place. The cosmic story has chapters, and we live in one of the brightest pages. The story begins about 13.8 billion years ago, with a single, almost incomprehensible event we now call the Big Bang. Space, time, energy, everything that exists, began expanding from a state so hot and so dense that the laws of physics as we know them do not fully apply. Within a fraction of a second, the universe doubled in size many times over. Within minutes, the first atomic nuclei formed. For the next 380,000 years, the universe was a glowing fog, too hot and dense for light to travel freely. And then, finally, it cooled. Atoms formed. The fog cleared. And for the first time, the universe became transparent. The afterglow of that moment is still detectable today as the cosmic microwave background, the oldest light we have ever observed. For the next 100 million years or so, the universe was dark. There were no stars yet, no galaxies, no planets, no light to speak of anywhere. Just enormous clouds of hydrogen and helium drifting through expanding space, pulled gently together by gravity over millions of years. And then, somewhere, in some clump of gas that finally grew dense enough, the first star ignited, then another, then thousands. The universe began to glow. These first stars were enormous, hundreds of times the mass of our sun. They lived fast, burned hot, and died young, exploding as the first supernovae and seeding the universe with heavier elements. Without them, there would be no carbon, no oxygen, no iron, no life. Everything you are made of was created inside one of these early stars, or inside the stars that came after them. Over hundreds of millions of years, those early stars gathered into the first galaxies. The James Webb Space Telescope is now showing us those very objects, galaxies that formed within the first few 100 million years after the Big Bang, far earlier than scientists used to believe was possible. The universe got busy. Galaxies merged. Black holes grew. New stars formed inside the wreckage of old ones. And somewhere, in one ordinary galaxy on the outskirts of a larger group of galaxies, about 4.6 billion years ago, a cloud of gas and dust collapsed into a new star, and a series of small worlds began to form around it. One of those worlds was Earth. About 1 billion years after Earth formed, the first single-celled life appeared. 3 billion years after that, complex multicellular organisms. A few 100 million years after that, the first animals. And about 300,000 years ago, almost in the very last sentence of cosmic history, humans. We are not a footnote in the story of the universe. We are the latest line so far in a chapter still being written. But chapters do end. About 5 billion years from now, the sun will exhaust the hydrogen at its core. It will swell into a red giant, large enough to engulf Mercury, then Venus, and likely the Earth itself. Eventually, it will shed its outer layers in a glowing shell, a planetary nebula, and collapse into a small dim white dwarf, gradually fading over hundreds of billions of years. Long before that, in roughly 4 billion years, our entire galaxy, the Milky Way, will collide with our nearest large neighbor, the Andromeda Galaxy. The night sky over Earth, if Earth is still here, would be filled with the slow, soundless choreography of 2 galaxies merging into one over millions of years. Eventually, they will form a single, massive galaxy. And that galaxy, too, will not last forever. Far in the future, perhaps 100 trillion years from now, the universe will run out of the raw material to make new stars. The brightest, hottest stars will be long gone by then. Only the smallest, dimmest red dwarfs will remain. And one by one, even they will burn out. The universe will enter what cosmologists call the degenerate era. A time when no new stars are forming. A time when the night sky everywhere is mostly empty. After that, on timescales so long that human numbers stop feeling meaningful, even the dead stars will slowly decay or fall into black holes. And black holes themselves will slowly evaporate over inconceivably long stretches of time. Eventually, after stretches of time so long that calling them numbers stops feeling meaningful, the universe will reach what is sometimes called the heat death. A state of near total emptiness, a few stray particles drifting forever in a space that keeps expanding. No stars, no planets, no light, no structure of any kind, just darkness and an unmeasurable cold. This is, as far as our current physics can tell us, the most likely long-term fate of everything. So when you look up tonight, remember this: the universe will not always be like this. The stars you see, the galaxies that fill those photographs from the Webb telescope, the warmth of the sun on your skin, all of that belongs to a specific era in cosmic history. A brief, lit, vibrant era. We do not live in the middle of nothing. We live in the middle of the brightest possible moment of everything. And nothing in the universe, including the universe itself, gets to stay.